All right. Well, thank you all for coming. Before I start out, I just want to say 44Con has a really special place in my heart because 6 years ago, this is the first conference that I ever gave a talk at. And since then, it's been a wild ride. But if you want to actually see a video of how not to do a talk, that's available on YouTube for you all to enjoy. Some really good stuff happened during that talk, like my laptop died. There was a bunch of stuff that, yeah. So if you ever need a reference point on like things to not do during a talk, definitely go see that one. I think it was called MITMF. It was like in 2000 and it was like 6 years ago-ish at this point. But yeah, it's great to be back again. Hopefully this talk won't suck as bad as that did. So I'm going to be talking to you about .NET Tradecraft, specifically how to fuse, if you will, scripting languages into your .NET Tradecraft. And there's a bunch of reasons why we want to do this in the first place. The main reason why I even went down this rabbit hole was to shift back the paradigm to PowerShell style like attacks, okay? Because with the recent migration to C# tooling, if you're not familiar, the offensive community has been migrating all of their offensive tooling to C# from PowerShell. That's mainly because up until .NET 4.8, there weren't any protections in the underlying .NET framework, and I'm going to be discussing this during this talk as well. But operationally speaking, that whole tool migration has brought a lot of disadvantages. One of them is that we're now switching to a compiled language, which means that everything is not dynamic anymore. We have to compile things server side, client side, all of this stuff. During limited time engagements, if you haven't set up your like continuous integration pipelines or anything like that, compiling stuff can be time consuming and often brain hurting. So this is my approach to doing that. I really like the old way of doing things with PowerShell. I wanted to continue to do things that way because of all the flexibility is provided. So this is sort of my approach on like solving that problem. This is the obligatory Who Am I slide. My name is Marcello. I go by Byte Leader on the Twitters. I work for Black Hills InfoSec. I've written a bunch of stuff over the years. If you're inclined to look at other stuff that I've written, you can check out the stuff at that GitHub profile there. And this is the agenda for today. So we're going to be covering some motivations. We're also going to be going into some key .NET framework concepts because to understand what I'm going to be talking about, we sort of have to be all on the same playing field. That's going to be a very high level introduction to the .NET framework because I don't want to bore you if you're not interested at all with .NET development or anything like that. But we're definitely going to have to get on the same playing field. Then I'm going to be actually talking about how to embed interpreters and engines. So the meat of this talk. So like how to actually go about embedding third-party or Microsoft officially supported scripting languages into your C# assemblies or really any .NET language. And then I'm going to be doing some demos about how to bring your own interpreter demos. So BYOI is the term that I've been starting to call this type of payload. Bring your own interpreter. I'm going to be demoing some for you today, and hopefully they'll work. So let's all start praying to the demo gods right now. And then I'm going to be talking about if you didn't want to embed these interpreters and engines at all, I'm going to be talking about how to actually go about weaponizing some of these concepts that I'm going to be explaining to you really quickly without doing any in the embedding. Also, I'm going to be demoing Silent Trinity, which is a C2 framework that I've been building over the course of the past year-ish now that sort of tries to weaponize these concepts and put a nice little ribbon on top of everything. So I'm going to be demoing that as well. Then we're going to be going over detection, and we're going to be talking about and then we're going to be open for question and answers. Okay, so like I said before when I opened up, the key motivation behind this originally was just to find a way to execute PowerShell without PowerShell, okay? And going into this, I really didn't have any .NET development experience. I didn't have any C# experience. I didn't even know how the hell anything worked. So needless to say, I was venturing into unknown territory. But again, like because of the whole C# tooling migration, it was just a matter of time. I'm gonna have to need to learn all this stuff. But I really did not like the fact that you just had to compile stuff all the time now. Like that, I didn't like that at all. And it really made me feel nostalgic of the PowerShell era where we could just like throw down source code and done. That's it, right? And that's because we've started migrating over to C# mainly because of all the PowerShell defenses that have been implemented in the PowerShell runtime itself. So AMZ, script block logging, transcription logging, all this stuff made the red teaming community migrate over to C#. I really like scripting languages as well. I'm a Python fanboy. The minute I heard like, oh, we're all migrating over to C#, I was like, no, please stop. And also like developing weird tools. So whenever a new concept comes out, I tend to just like take it and see how weird I can get with it. So there was a bunch of motivations behind doing this type of work. So this is where we're going to have to sort of get all on the same playing field and learn a bit about .NET development and some key .NET framework concepts. If you've dealt with C# or .NET at all, you've probably heard the term .NET assembly been thrown around a lot. Okay, and the question that I get asked a lot is, well, can you please explain to me what is a .NET assembly, because I still don't understand. Well, a .NET assembly, all you really need to know is a .NET assembly is a single unit of execution that any .NET language can interpret and execute. Okay, and I'm not going to be delving into like the format of a .NET assembly because that can be a whole talk of its own. But the key part of that sentence really is any .NET language can interpret and execute, because that actually has some pretty interesting implications. How do you go about generating a .NET assembly? Well, it's pretty easy. All you take is any .NET language, okay? So in this case, C#, but really it can be anything, any .NET language. That's another key important thing to understand, by the way. The .NET framework isn't C#, C# isn't the .NET framework, okay? The .NET framework is nothing more than a set of tools and infrastructure that Microsoft developed for you to build your own language, okay? The de facto language of the .NET framework is C#, but they're not coupled together. Like .NET framework is literally just a framework for you to build your own language on, okay? So in order to actually generate .NET assembly, all you really need to do is take any .NET language and compile it, okay? So C#, pretty easy. Write your C# code, Visual Studio compiles into a .NET assembly, which you can execute, right? This is, in the .NET world though, this is, things start differing a lot immediately, like when you try to compile it to a DLL. So if you take that same C# code and compile it to a DLL, that DLL is also a .NET assembly, okay? So from the .NET framework's perspective, that executable and DLL really are the same thing, which might differ from what you'd expect from C++ or C, which are unmanaged languages, so outside of the .NET framework, okay? So that's an important key thing to understand. These are both .NET assemblies. Also, .NET assemblies, like the format, are almost completely different from native executables and DLLs, okay? So just because they have the same extension does not mean they're the same format, okay? So that's also another important thing to understand. So remember when I talked about .NET assemblies earlier? Like it's a single unit of execution that any .NET language can interpret and execute. That has some pretty interesting consequences. So these are 3 officially Microsoft supported languages. Okay, so we +, PowerShell, if you didn't know, is a .NET language. There's F#, and there's a bunch of others. There's VB.NET, there's C++, Clyde, which is like mixed mode assemblies, which is a really weird world to tread in because it's like it's C++, but it's also .NET. It's really weird. But there are also a bunch of other third-party .NET languages, because again, like the .NET framework is nothing more than a set of infrastructure for you to build your own language. So Microsoft has built some languages with it. Third parties have also built some languages with it. And these languages are very interesting for a number of reasons. And we're going to be going over some of these. There's IronPython, for example. So IronPython is nothing more than a .NET implementation of the Python programming language. So you got normal Python, which is based on C and C++, C and C Python, right? IronPython is based on the .NET framework. Okay. There's also Booleang. How many of you have heard of Booleang before? Well, you don't count, but okay. But so Booleang is amazing. Booleang was originally developed, and I'm going to be talking about Booleang a lot. I'm going to be ranting and raving over it in the next couple of slides, because Booleang from an operational tradecraft perspective is amazing. And it was originally developed, I found this out recently, it was originally developed for the Unity gaming engine to provide scripting capabilities to it. I had no clue. I've been using it for malware all this time. So that was something new I found out, and someone at DEF CON approached me and told me about that. That was amazing. And then Iron Ruby. Iron Ruby, again, like, it's just another language built on top of the .NET framework. It's similar to Ruby in almost every way, shape, or form, but instead of calling C APIs, you're calling .NET APIs. So these languages some of them, most of them are scripting languages. So Booleang and IronPython and IronRuby are interpreted languages. Okay, what that means is that from an operational perspective, these are really, really interesting because they allow you to dynamically call .NET APIs through a scripting language, which is what exactly PowerShell allowed us to do. Okay, so what we're basically doing is we're going back to PowerShell style like attacks, right? Because PowerShell allowed us to dynamically call .NET APIs, which allowed us to do all the great things that as red teamers we all know and love, like injecting shellcode and interacting with low-level API calls, only in IronPython, Booleang, and IronRuby. Okay, so like this is some pretty. I personally think this is some pretty interesting stuff. And in order to understand why the red teaming community migrated to C#, we need to sort of also understand like that all the defenses of the PowerShell runtime, all the defenses in the PowerShell runtime are only in the PowerShell runtime. Okay, so the minute you jump to another .NET language, you're automatically getting around all of those PowerShell defenses. That's also like that's the main reason why we've been jumping to C#. There's also some really interesting, the .NET languages in general have some really interesting properties and functions that allow us to do some pretty cool stuff. So assembly.load, for example, and assembly.load is by far like the main culprit of why C# and .NET are like really, really sought after for red teaming tradecraft. Okay, it's because assembly.load is fantastic because it accepts a byte array among many other things, but what that means is you can just throw it an assembly. So remember how I told you before, like generate .NET assembly by compiling C#, you get it, compile it into an executable or DLL. If you throw that executable and DLL to this function, it'll automatically load it in memory. Okay, and now all of a sudden you have access to all of the code that you've defined in your C# source code. Okay, so basically this one function is basically the equivalent of having reflective PE and DLL injection natively supported by a language, okay? Which is kind of crazy when you go to think about it. And this is the main reason why a lot like that red teaming tradecraft has been migrating over to .NET and C# languages because this one function offers us so much flexibility. So like I said before, like the main reason why the red teaming community has jumped to C# is because as of very recently, all of the defenses were put into the PowerShell runtime by Microsoft, but they weren't actually put into the underlying framework. Okay, so what this means is that to bypass all of the PowerShell protections, all you have to do is just jump to another .NET language. And the red teaming community has jumped to C#, just because it was a very natural transition from PowerShell, because in order to do some low-level PowerShell stuff, you sort of needed to do C# anyway, and they're very similar. But so my thought, like this whole talk is based around the idea that, well, we've jumped to C#, but what happens if we jump to IronPython instead, right? What happens if we jump to Booleang or IronRuby? Because these are scripting languages. They're not compiled languages. So those gives technically, they would give us the same amount of flexibility that PowerShell gave us, only in Python. Only instead of coding in PowerShell, we'd be coding in Python or Booleang or Ruby. So I thought this would be like a really interesting idea to try out. And as of recently, these defenses weren't put in place in the underlying framework. What that means is that, like we just jump to another language, but as of .NET 4.8, AMSI has been integrated in .NET Framework, although when it comes to these .NET scripting languages, AMSI really doesn't have that much insight into it. And I think you'll start to understand like why when I start demoing this stuff. So that's the basic principle around this talk. We're gonna be making some weird shit today. It can get weird real fast, especially once you start embedding stuff. Another consequence of doing this is that because all of these languages are interoperable with each other, because they're all based on the same framework, right? So what that means is that IronPython can do whatever PowerShell did. PowerShell can do whatever IronRuby can do. Booleang can do whatever C# can do. They're all interoperable with each other, which means you can also embed them within one another. So you can take the IronPython engine, embed it in a PowerShell script, embed that into a Booleang script, and embed that into a C# script, and keep on going and going and going, and everything will just work. because they're all based on the same framework, the underlying framework. They all can interpret and execute C# assemblies, .NET assemblies, so they're all interoperable with each other. So what this means is that you can embed them. And if you've been using any pen testing or PowerShell red teaming tools recently, you've probably done this once or twice without even knowing it, okay? Because there are some tools out there right now that allow you to execute PowerShell code within a C# binary, or C# within PowerShell, okay? So this is basically the same concept. All I'm saying is, hey, well, we've been using PowerShell and C# to do this. Why not embed the IronPython interpreter instead, or the Boolean interpreter instead? So this is just like some code from Powerline, but basically the same code you can take from like NPS or PwnShell if you're familiar with those. They embed the PowerShell run space within a C# binary, right? And you can do the same. You can do the same thing in reverse. You can take C# code, embed it in a PowerShell file. You might, if you're dealing with like red teaming tradecraft, you might not want to do what I just mentioned, just because if you do decide to compile C# within PowerShell, by default, it'll drop artifacts to disk, okay? And you'll see with some of the demos that I'll be showing you that with other third-party .NET scripting languages, that isn't necessarily the case, which is great from an OPSEC perspective. So when you start embedding these interpreters and engines, or whatever the language calls them, you're going to find that there are some common issues / code patterns that you're going to have to keep using over and over again in order to solve certain problems. The main issue is that most of these languages only support .NET 4.0 and up. Although in my mind that really isn't an issue, because the reason you want to do this in the first place is to not use PowerShell. So if you're running any .NET version lower than 4, you can just revert back to PowerShell tradecraft because none of those protections are in place, but that's just my opinion on that. The languages usually are going to need some DLLs. Those DLLs are usually not on disk. So what that means is you're going to have to find a way to load them on runtime. And you can do that pretty easily with .NET. There are some certain events that you can hook, which I'll talk about in the next few slides. That basically you can insert any logic into them and you can automatically resolve those DLLs. So like I said before, like the biggest problem you're going to probably run into is that those DLLs aren't present on Windows by default, right? So like IronPython, for example, requires 4 DLLs to run. Boolean requires 3. ClearScript, which I'll be talking about, requires 1. So the problem arises is like, how do we get these to load on runtime, right? Well, thankfully, like .NET provides us with the assembly resolve event, okay? So you can hook this event in .NET and put any logic you want into it, okay? So what that means is that when you run your C# assembly that embeds like the Boolean compiler, for example, that C# assembly will run whatever code you put in that event to resolve its dependencies, quote unquote, okay? So if you, for example, put some logic in there that goes out to the internet, downloads the DLLs from like a server, and load them on and pass that to assembly.load, that'll work. Like, so you can automatically make your C# assembly or any of these interpreters just automatically download these DLLs when they start up. So that's probably the best way to do it. Boolean is special in this sense because usually, hooking the app domain assembly resolve event, you're going to need to do that with most scripted .NET languages because IL merge, if you're not familiar with IL merge, it's a tool that basically allows you just to pack all of the necessary DLLs into a single executable. A lot of these .NET scripting languages don't really work with IL merge for one reason or another. So hooking this assembly resolve event is probably the main way to deal with this issue. Boolean, on the other hand, is special in this sense because it actually does support IL merge. So if you do decide to compile a Boolean script, you can actually use IL merge with it, which allows you to do some really fun stuff. So now I'm going to be starting to demo a lot of these concepts that I've talked about. And hopefully I've relayed this information to you in a digestible manner. But IronPython is the first .NET scripting language that I started out using, mainly because I'm a Python fanboy. So I was like, okay, well, this is easy, right? So I started, this was the first language that I put into Silent Trinity, which is the C2 tool that I wrote. But unfortunately, IronPython has some major downsides. One of them being, from at least the red team tradecraft perspective, one of them being that the module that you use to do pinvoke basically which allows us to call like native Windows API functions to inject shellcode and all that stuff. It works when IronPython is on disk, but when you load the IronPython runtime in memory and then try to do pinvoke, it just breaks. So right out the gate, IronPython wasn't exactly the best when it came to red team tradecraft. Okay. So all of these code examples that I'm gonna be executing and demonstrating are on that GitHub repo right there. So they're publicly available. So if you want to follow along while I demo or take a look at them after, you can go to that link. I'm gonna be demoing invoke ironpython.ps1 right now, but there's also an example on that GitHub repo that embeds the IronPython interpreter within a C# binary, so you can use that, so you can do that as well. And because again, like you can embed these languages within any other .NET language, okay? IronPython requires 4 .NET assemblies to run. Two of them have been written by Microsoft. They're not signed, unfortunately. But those basically just allow IronPython to interface with the .NET DLR, which is the dynamic language runtime, which is the feature that allows you to build .NET scripting languages. Okay, so I'm going to be demoing invoke IronPython here real quick. And this is a really, really simple example, okay? And I'm going to be embedding the IronPython runtime within a PowerShell script and then executing Python code within the embedded runtime, okay? So this is just a little simple IronPython script that I'm going to be executing. Notice that instead of like Python libraries, is that font okay, by the way? Can you see in the back? Okay, sweet. Notice that I'm not importing Python libraries, but I'm importing .NET APIs. Again, that's because these are .NET scripting languages you can dynamically call .NET APIs, right? So this is just a little simple IronPython script that allows you, I'm just printing hello from IronPython, okay? These are the 4 assemblies, .NET assemblies, that are needed to actually spin the IronPython runtime up. And I'm just loading them. This is just some code that just makes it all a little bit prettier, and loading those assemblies in memory so that we can actually spin the IronPython engine up. This is the code responsible where all the magic happens. So you can see that once we load those assemblies, we have access to the create engine function within the IronPython hosting API, which allows us to spin the engine up. You can actually set global variables to the engine itself before actually running anything. So in this case, we're just setting just the CLR type source, just a little variable to demonstrate that you can actually set global variables. And then we're executing the embedded script, okay? So I'm going to run this real quick. There you go. So hello from IronPython. Okay, so we were basically able to run IronPython code within a other .NET scripting language. So you're probably wondering, okay, well, this is great, but like from an offensive perspective, what did this mean? Well, if you think about this for a second, what this means is that this is basically going back to the old ways that we use PowerShell, right? Because once you load the IronPython engine here, none of the PowerShell protections in place have any visibility into the Python code that you're executing within the embedded IronPython engine, because that little create engine function there is immediately making a transition to another .NET language where none of these defenses are in place, okay? So the minute you start running IronPython code within that IronPython engine, PowerShell is like, I have no clue what you're doing anymore. You feel free to run whatever you want, okay? So this is just an example. So, and whatever you do with PowerShell, you can do within IronPython or any other of these languages that I'm going to be demonstrating, by the way, okay? So like if you wanted to inject shellcode, maybe not with IronPython because, like I said before, the pinvoke module that allows you to do that is broken. But in Booleang, you can totally do that, and I'm going to be actually demonstrating that in a second. But with, like, you can do whatever you could do with PowerShell within any of these languages. Let's go back to my slides here. So that's just a really stupid, simple example, okay? But let's actually do something, worthwhile doing. And this is where Booleang comes in. So Booleang is amazing for a number of reasons. And every time I go to the wiki page, so Booleang is hosted on GitHub. It's a free open source .NET scripting language. The wiki is amazing. And especially if you're a red teamer, I encourage you to go look at the wiki and the examples in there, because some of them are just pure gold from like a offensive tradecraft perspective. It is sort of like a love child between Python and C#. So, which is great from my perspective, because again, I'm a Python fanboy. So it takes constructs of both languages and sort of mishmashes them together. You'd expect that to be somewhat weird, but it's actually a very beautiful language. Like the more I code in this, the more I think like this is just a beautiful language. And it was developed by one guy too. So definitely show him some love by making malware out of it. I think that's the least we can do. Again, it's heavily inspired by Python, like that you can use like for loops as you'd expect in Python, using statement, like the context managers, all that stuff. But the best thing about Booleang is that it natively supports the DLL import attribute. So it actually has pinvoke that works from within memory and on disk, which is fantastic. So now what this means is that we can do anything. We can actually do like anything from an offensive tradecraft perspective. So this is a 16-line Booleang script that imports the mini dump write dump API, which allows us to dump memory, and basically just makes a memory dump of LSASS and puts that on disk. Okay, 16 lines, and no Visual Studio required, by the way. This is just like Sublime Text and the Booleang interpreter and compiler. And you can just take, if you don't want to embed the Booleang interpreter, like I said before, you can take the script and compile it to an executable using the provided compiler that the Booleang runtime gives you, okay? So you can really quickly weaponize any of these examples that I'm going to be showing you. So that's the main beauty of this as well. Another thing about Booleang is that I think from, again, like this is, I'm giving you my current understanding of how Booleang works, which might change in the future, but I think it directly compiles to MSIL. So what that means is that you can actually take this script, compile it, and then with the resulting binary will work on any version of .NET. Doesn't matter what version of .NET the endpoint has, it'll just work. It even works on like Windows 7, and like I've tried even old versions of like Windows XP and stuff that had .NET on it, and it seems to work everywhere that I've tried it on. If you start referencing the actual Booleang infrastructure from within the script, so like if you import like Booleang, the Booleang assemblies, then it won't work. It'll only work on .NET 4.0, okay? Because the Booleang requires .NET 4.0. But if you don't reference anything in the Booleang infrastructure, then you're good to go. So I'm going to be demonstrating invoke jump scare right now. And again, like these code snippets are hosted on that GitHub repo. So this embeds the Booleang compiler within a PowerShell script, and we're going to be injecting shellcode through the embedded Booleang compiler, okay? Boo requires 3 .NET assemblies to run, so it's even better than R and Python, 1 less assembly to load. So the example I'm going to be demonstrating right now is embedding the Booleang compiler within PowerShell, but again, like there's an example on that GitHub repo that embeds it in a C# executable as well, okay? So let's go back to our VM here. This is invoke jump scare, okay? I put some description in there. Again, like you'll see that it's a common pattern that you're going to have 3 .NET assemblies to actually spin up the engine or interpreter, whatever the language calls it. This is our shellcode, which is pops calc, okay? This is generated from MSF Venom. This is in the PowerShell script, but obviously, like if you wanted to make this a lot more stealthier, you could probably, you can totally take this shellcode and put it in the Booleang source, so that like from a PowerShell like script logging point of view or AMSI point of view, there really isn't anything to trigger on, right? And also, what's in this particular example, I'm actually loading the Booleang source from another file on disk, but just by literally commenting out these 2 lines, you can just embed the source within the PowerShell script itself, so it's all self-contained and you don't have to worry about like other files on disk. And then here, this is where the magic happens. We're basically just spinning up the Booleang compiler, and we're telling it to compile to memory. Now, what's another thing great about Booleang is that when you set true to this compile to memory flag, it actually compiles to memory. So as opposed to embedding C# within PowerShell and calling add type on that, where it leaves artifacts to this, Boog just compiles straight to memory. There's no artifacts left on this, which is amazing. And then over here, we're just executing the main function of the generated assembly, and then it'll execute the shellcode. Now I'm going to actually show you the Booleang source for this. So this is the PowerShell script embedding the Booleang compiler, right? The actual Booleang code that we're going to be executing is this. Okay, so this is Booleang, and you can see that I ported over some very common shellcode injection techniques. We're doing all the DLL imports necessary. This is the QU APC shellcode injection method. Pretty straightforward. The inject self, which is uses wait for single object injection technique, and inject remote, which is create remote thread. Okay, so let's pop calc. Demo fail because it does not exist. I beg to differ. Oh, no, he's right. 1 second. Let's try this again. So what's up here? Open. Okay, let's try that one more time. No, I guess not. Okay, well, let's do this. Let's try this one more time, because I really wanted to show you this. Kind of sucks. Okay, that's weird. Okay. And this is opened from desktop. All right, one more time. All right, you know what? I'm gonna do this. Close this out. And then jump scare. Edit. Okay. Hey, there you go. Took us a while, but we did it. So what this did, just to recap here, okay? We've embedded the Booleang compiler within PowerShell. We then read some Booleang source code off disk, but you can as easily embed it in here or download it from the internet, for example, which would be the stealthier approach probably. And then used Booleang source to actually call all of our native APIs to execute shellcode, and then executed some shellcode. Okay, so again, hopefully I've conveyed this information in a way where you're probably realizing all the possibilities that this opens up. But yeah, I find this to be pretty interesting. So ClearScript. So ClearScript is a recent discovery of mine. This is an officially Microsoft-supported project, okay? And ClearScript was specifically designed to actually add scripting capabilities to your .NET language, okay? And what's great about ClearScript is that it has what I think is its own JScript and VB script implementation. Now, I say I think because I still am not able to find the COM calls necessary for it to spin up the Windows script host environment. So because of that, I'm assuming that it uses its own JScript implementation, although I can't find the code anywhere for me to actually say for certain, because it's written in a really awkward way. But this allows us to do a lot of cool stuff. For one, it allows us to access JScript from ClearScript itself. So JScript, if you're familiar with Red Team, Tradecraft, and Subt's work, Casey Smith's work recently, there are a bunch of functions that JScript allows us to access that can download SCT files from the internet. Okay, so SCT is just whole another talk basically, but you can just embed commands within SCT files or shellcode within SCT files and downloads from the internet and execute them through JScript. Okay. The problem is the built-in version of JScript in Windows uses the Windows script host environment and it has Hamzy in it, right? From what I understand, since ClearScript has its own JScript implementation, it doesn't go through Hamzy. So you can just call whatever you used to do in JScript within ClearScript and it'll just work, okay? And this is an example of using JScript within C#. I'm going to be demonstrating invoke ClearScript, which is ClearScript within PowerShell. And again, like all of these code snippets are available on the GitHub repo there. What's great to note, now I'm just going to reopen this real quick. Invoke ClearScript, there you go. So ClearScript also supports a high-performance V8 JavaScript engine, which requires you to have 3 additional DLLs. If you just want GScript and VBScript, you can just have 1 DLL and you're good to go. So what we're going to do in this demo is we're going to use the getObject function in JScript to actually download an SCT file from a HTTP server that I've hosted on my laptop here, and that's going to execute calc. Okay. So just looking at the code real quick, this is just the embedded ClearScript DLL. We load the assembly we load the assembly and then call the ClearScript engine. Another great thing about ClearScript, by the way, is because I don't know, you're gonna have to talk to Microsoft to understand like why this is even a thing, but you can expose the CLR to JScript through the ClearScript implementation. So what this means is that you can call .NET APIs through JScript itself, which is kind of crazy. So like here we're starting up the JScript engine where we're saying allow reflection, which is fantastic. So we can call assembly.load from JScript, which is mind-boggling. And then we're basically importing like .NET APIs in the JScript source itself. So we're importing system.core, system reflection, system runtime interrupt services. We're then just printing hello from the CLR inside ClearScript. And then we're going to download the actual SCT file. So I got a Python HTTP server here up and running. There you go. So now all I have to do is hit play on this bad boy and ClearScript. And there you go. And I just want to point out that, that throughout this entire demo, this has been turned on the entire time. Manage settings. There you go. With the exception of automatic sample submission. So because, I don't want Microsoft seeing my malwares before I decide to burn them. But yeah, throughout the rest of the demonstration, that's going to be on the entire time. So like, again, I'm not sure if this goes through WSH or AMSI at all, because again, I can't find the code necessary for that to do that. So that's something that I would love to hear if you have. I haven't had the time yet to do like a thorough code review or inspection of ClearScript, but that would be interesting to see if like anyone here knows or can go through and like see and like validate this is actually a thing. Okay. Okay, so I demonstrated 3 languages here today, but there are many more, and some of them are really, really interesting. We got some Lua implementations. So if you ever wanted to like write your post exploitation or in malware in Lua, I got you, fam. I got a JavaScript implementation. I keep saying this at every conference because I haven't had the time to try this out. But it would be interesting if you embedded the JavaScript engine within a C# assembly and threw it a beef hook. I wonder what would happen. Like the idea of beefing endpoints is kind of hilarious, so I kind of want to try it. But I'd assume it'd break because it's not a browser, but it'd be interesting to find out. .NET WebAssembly, that's a really interesting one. And the more I think about this, the crazier it gets and the possibilities that this opens up. But you can actually execute and create WebAssemblies from within a .NET application, okay, in memory. So that allows you to do that. So that opens up a lot of interesting and weird possibilities from like tradecraft perspective and like shenanigans you can pull with that. So I'm going to be definitely taking a look at that more closely when I have the chance. There's also IronPython 2. IronPython 3 is in the works. Hopefully, it would be great if they fix the pinvoke issue by IronPython 3. As it is right now, I doubt that will be ready by the EOL of Python 2 next year. But hopefully, they'll finish it up somehow. There's also IronRuby. But by far, like out of all of these that I've found so far, Booleang reigns supreme in terms of just like tradecraft and Booleang and ClearScript. Booleang and ClearScript. I had those two reign supreme in sort of like operational flexibility and tradecraft. Okay. And again, like the great thing about this is because the .NET framework is just something that gives you tools to build your own language. It's not necessarily coupled to a specific language itself. All of these scripting languages come with their built-in compilers usually. So what this means is that when you download the IronPython runtime or the Booleang runtime, you can write your IronPython script with Sublime Text and then run it through the provided compiler, and it'll turn it into an executable or a DLL. Okay, and so if you're just saying like screw this embedding stuff, it's too hard, I don't want to deal with it, you can just take those snippets that I just showed you on that GitHub repo and just compile them, and you can just run them on endpoints, which I think is like from a flexibility standpoint, that's awesome because you don't have to set up your development environment with like Visual Studio, and you don't have to deal with any of that. You just compile it and it runs. Okay, so now I'm going to be demoing Silent Trinity. Okay, and Silent Trinity is the C2 framework that I wrote. It's publicly available. It's at that URL. That sort of tries to wrap these concepts in a nice little ribbon. And it's got some pretty interesting stuff. It's actually before I demo it, recently I've released the version 4.0. It's pretty, like, it's getting there. Slowly but surely it's getting there. It's asynchronous. So the whole thing is asynchronous. It's very similar to Cobalt Strike. It's a team server architecture. So there's a client and a server, multiplayer, multi-server, and you'll get an idea during the demo. It supports multiple callback domains now. You can customize the jitter and sleep intervals. And you can actually kill sessions now, which is helpful. Uploads and downloads. You might think, okay, uploads and downloads, what's the big deal? That took a long time to implement. Uploads and downloads is hard, but it also opens up a lot of possibilities in terms of like automating attack flows. It also integrates PyPyCats now, which I'll be demoing. And as of last night, I was up until 4 a.m. dealing with this, but I actually integrated an Azure CI build pipeline. Okay, so what this means is that because the way all the stagers, which I'll be demonstrating, are implemented right now, they have a C# assembly in it. .NET 4.8 has AMS integration, so it might start flagging on that C# assembly. So when it does that, all you need to do to get around it is just do an HTTP request to a certain URL, and Azure will automatically build a new assembly for you and push it to the repo, okay? And in the future, what I think I'm going to be doing is hooking this up to Patreon. So if you give me $1, you'll also get a stager, which is kind of cool. But I think that'd be kind of cool. So there's also lots of bug squash, and there's around like 60 post-exploitation modules now because I've gotten some pretty awesome contributions. It's got everything from Privest to Kerberoasting to like a Rickroll module if you feel so inclined. Like there's a bunch of them now. All in Booleang. And again, so before I go to the demo here, I just want to just really drive the point across and how flexible this whole thing, this system is, right? So we're basically just embedding the Booleang compiler in another .NET language. Like every Silent Trinity stager is just embedding the Booleang compiler in a .NET language, okay? So what this means is that the modules are just source code, okay? So this is like the cache GPP module in Silent Trinity, and it's just source code. And because it's source code, you can make real-time edits to this module, and every time you run the module, like those edits will be just pushed down to the endpoint, right? Because it's server side is just source code. So if you wanted to like edit this on the fly for some reason, instead of compiling stuff as you would do with like C# tradecraft and like server side and then sending it down, you can just do it all in like your preferred IDE, and it's source code, so you can just edit it as much as you want, okay? Which I think is pretty cool. Okay, so I'm gonna get rid of this real quick. All right, so I have my Silent Trinity, and how are we doing on time? Okay, I have my Silent Trinity team server here. I'm going to start this up, and I think we're good to go. I have my client here, start that up, and you'll notice that I passed it whoa, that's some funky stuff going on there. I passed it an RC file, so if you're familiar with like Metasploit, you just put a command in line by line, and that just helps automating a lot of stuff. Again, it's team server client, the architecture. So what this means is that the client supports multiple users, so you can share shells between each other. And from the client, you can manage multiple team servers as well. So it's multi-client, multi-server. So I started a listener here in the client. So that's our HTTPS listener. I got more comms coming. I just have to have the time to actually implement them. But right now, the ones that work are HTTP and HTTPS, just to give you an idea of what this thing can do. So once we have that, we have to generate a stager. And there are a bunch of them right now. Some of them I've released, some of them I have not. But once I clean them up and everything and actually use them on an engagement, I might release them. But for now, I'm just going to demonstrate the PowerShell stager. So the way you generate stagers is you just use PowerShell. And you notice it's got some fancy autocomplete options, which I personally like a lot. And then once you select the stager, there are usually some options that you can set. But if you're just good to go, you just generate and then the name of the listener. And it'll just automatically do everything for you. The stager gets generated server-side, gets sent down to the client, and gets saved on the client's machine. And then, in this case, it's PowerShell. I already copied that stager to this Windows VM here. Okay, so let's do that real quick. So I'm just going to execute the stager on this because, you can do this with an IEX cradle. I'm just executing this for demonstration purposes. And there you go. So notice a couple of things. One, define that it didn't trigger, which is interesting. And two, we have a Silent Trinity session now. So it did a lot of things under the hood, by the way. It uses all the comms are encrypted. So it uses encrypted key exchange to actually do the initial Diffie-Hellman key exchange. It encrypts the public key, sends it to the server, and vice versa. Downloaded the stager, which contained the Boolean DLLs necessary for the actual compiler to spin up on the endpoint. And then we also streamed down the actual stage code. So what's great about this system too is that the actual code that does all the malicious stuff is not in the PowerShell stager or the C# assembly or whatever's on the endpoint because it's dynamic, right? So if you were to, unless you do a memory dump of the live process running, if you were to just do reverse engineering on the embedded C# assembly or the PowerShell script, you wouldn't find the actual malicious code there because it's just getting executed on the fly when you stream it down, which I think is also a pretty interesting thing as well. So we've successfully compiled the stage code, and now we should have a session. There you go. So once we have a session, I'm going to be demonstrating, because I'm sort of short on time, what I'm going to be demonstrating is the new mini dump module, which integrates PyPyCats, which does a lot of things. So you can see that we got a session here. If you're familiar with Empire Metasploit, you'll feel at home in the UI. It gives you a little asterisk if the session that you get is admin. I'm going to go over the modules here, and you'll see that there's a lot of them. The power of open source. When it works, it's fantastic. When it doesn't, I kind of want to jump off a bridge. But I'm going to be demonstrating use mini dump module. There you go. So what this is going to do, it's going to use the mini dump write dump API, dump LSAS to disk, okay, and then dump LSAS to disk and then upload it to the server. Let's see what happens. Actually, now that I think, we'll see what happens. Let's give this a shot. There you go. So it dumped LSAS, and it's now uploading the dumped LSAS memory dump to the server. You'll probably notice it's really slow. That's because by default, it does a check-in every 5 seconds, right? But what we can do now is tell it to go interactive. So sleep 0. Oh, nope. Whoa, what's going on there? Okay, that was weird. Sleep. Do that in reverse. There you go. And again, it's asynchronous, right? So if it's running one job, it'll keep, that's much faster. If it's running one job, you can just keep sending it jobs down and it'll keep executing them. So it uploaded LSAS to disk and to the server, and these are the credentials that were in the LSAS dump, which were parsed using PyPyCats. So we're not even executing Mimikatz on the endpoint itself. All of the actual parsing of the credentials happens server side. We're just dumping LSS to disk on the endpoint itself, okay? Okay, so hopefully, if you weren't a .NET developer and you came to this talk, I know I threw a lot of information at you, but hopefully I've explained things in a concise way that you get an idea of why I think this is cool and like the flexibility that it provides you. If not, and I'm also going to be here until the end of the con. I'm actually going to be here for a full week. So if you have any questions after, definitely grab me and I'll be happy to answer them. So detection. So this is where things get a little funky because .NET 4.8 has AMSI integration, which already helps a lot in terms of just like mitigating like the common C# malware and stuff. There are reasons why AMSI kind of sucks, but I will be getting into that. Collect.NET events by manifestation is a way of just gaining some insight into the CLR itself. A lot of this stuff is open source or proof of concept. There really isn't a good way at detecting this at scale just because of the lack of tooling or tooling necessary to do that right now. Crab's ETW is the official Microsoft wrapper around ETW, which is a technology that allows you to detect this kind of stuff, but it's C++ and it's a wrapper. So it's more of like, here, take this thing that you can definitely detect this with, but you're gonna have to build your own tool, which in an organization that might not exactly be possible. Silk ETW is a really good open source solution to at least detecting some of this. It's, again, like open source, probably at scale, won't really help that much, but you can definitely put it on like specific high value endpoints if you're really worried about this kind of tradecraft. There's also Module Monitor, which can give you into some insight into like in .NET processes running on the machine, and some and possibly like malicious activity going on. I definitely recommend this talk by Luke Jennings at Black Hat 18. Memory Resident Implants Code Injection is live as well, which already started to talk about some of these concepts. And then there's also Countercept blog, which I think is an NWR company, and Hunting for Silent Trinity, which did a blog article on actually trying to detect Silent Trinity. And thank you for Ryan Cobb at Spectre also putting some of these together. I just took these and added some. I think these are by far like the best ways of going about trying to detect some of this stuff. But on the other hand, there's this. So if you didn't know, with Process Explorer, you can actually inspect the app domain of any .NET process, okay? And you can list all of the assemblies that are currently loaded in the process. You'll notice that if anything's loaded from memory, it doesn't have an assembly backing on disk, okay? I have yet to encounter a legitimate .NET application that loads stuff from memory, okay? So what this means is that if you do see like an assembly loaded in memory that doesn't have a file backing, that's a pretty good indication that something's funky going on there. And in this particular case, it's kind of obvious because, the Booleang interpreter and the IronPython interpreter are loaded, and, the Silent Trinity, it says we're in, Silent Trinity right there. But definitely, like, this is by far, like, the best way of, I think, just at least like a very general way of detecting this kind of malicious activity. Another important thing to note is that Booleang and IronPython, I would consider IOCs now. Like if you do see any .NET scripting languages loaded in memory, that's probably an indication that something funky is going on as well. So take that as you will. Questions?
Thank you. That was awesome. You mentioned earlier about nesting interpreters, so putting one inside of another. Have you seen any performance hits when you do that? And at what point do things start dying?
So obviously, like there are going to be some major performance hits once you hit like the 100th embedded interpreter. But from, I think I've embedded successfully like 4 or 5 altogether, and there was barely any performance hit. Yeah.
Any more questions? Probably time for one more. All right. Thank you very much.